Hello everyone and welcome to Unite Now. Thank you for joining us. My name is Amel Negra and I'm a creator advocate for the EMEA region at Unity. In this session, we will be covering introduction to version control. So let's get started. Here is what we will talk about today. First, we are going to talk about why we need version control and what are the options. Then we will focus on Git by explaining how it works. Next, we will mention the different tools that could be used with Git. And then we will dive into the demo, where we are going to start with setting up Git for a Unity project, go through Git actions like commit, push, and pull. We'll also see how to create and use branches and how to make pull requests. And then we will see how to merge and solve conflicts if there are any. Last but not least, we will give tips on using version control, including how to avoid the merge conflicts. So why do we use version control? The first reason is because we want to collaborate with the different members of a team on a project while keeping it synchronized. Or if for some reason you are using multiple computers to work on your project, you no longer need to use a USB drive or these kind of tools to transfer files with the latest updates of your project. You can also keep track of different versions of your project. You can use version control tools even if you are working alone on the project. This also lets you easily revert to previous versions if needed. Most importantly, at some point you will certainly need to do experiments. So you can safely do them without breaking the whole project, especially if you are working within a team. Now that we know why we want to use version control, it's time to look into the different options we have. First, Unity offers our own tool Collaborate, which is part of the Unity teams and is an artist-friendly solution. The tool allows you to easily collaborate with members of your team inside the editor. This option is recommended if you are working on a small team. Let me show you this page. On Unity Teams, you can navigate to this section, Create Together Faster, where you can learn more about Collaborate, and here you can find more information on how to get started with the tool. Another option is Git, which is the one we will focus on today, as it's among the most popular tools and it's also free. You can also use Plastic ASCM, which is designed for big projects. It's a powerful tool known for its efficient merging and support of huge files. So you can use it if merging and working with large files are one of your concerns. Another option is to use Perforce. For these two options, let me show you this page. I wanted to quickly show you the documentation where we provide information about setting up version control with Plastic ASCM and Perforce. You can see here we provide different modes for those tools. And we also have specific pages for Perforce and another one for Plastic ASCM if you want to know more on how to get started and set up those tools. And there are many other options. As I said, today we will focus on Git, and before diving into the demo, let's see visuals of how it works. The first step is initialization and clone. So here we have the first user who is going to initialize and create a new Git repository. Once it is created, the user will have access to the main branch. Then we will have other users that will come and join the project. So first, they will need to clone the repository to be able to access and edit it. So user 2 will clone the project, and so on for the other users. Now we will explain the three, I would say, must-know Git commands: commit, push, and pull. First, it's important to know that users can make local and remote changes. The local changes are only available on their computer, and the remote changes are available for everyone that has access to the Git repository. So let's say our user 1 made few changes. First, they will need to add and commit them. At this point, the user should add a message to mention the changes they have made with this commit. But for now, those changes are still local. They will only be accessible to other users when user 1 pushes those changes to the branch on the repo. Then we have two scenarios. The first is when user 2 didn't make any local changes yet. So first, they will need to pull the remote changes. These will update their local version of the project with the latest version available, in this example on the main branch of the Git repository. Then they can make new changes, add and commit them, and then push them. The second scenario is when user N has already started making changes in the repo, but we know that user 1 and 2 already pushed changes that user N didn't pull yet. In this case, user N needs to commit his changes first, and then he is not allowed to push them yet. the user needs to pull the changes made by other members of the team and then push his changes. In this situation, we suppose that the users are not editing the same files, so there are no merge conflicts. We will talk about merge in the next slides, and we will show example of merge conflicts during the demo. I also want to mention that in case you are not done with your changes, or for any other reason you don't want to commit them yet, but you still want to pull the changes made by others, or be on the latest version available remotely, you can use stash, which will allow you to temporarily save the changes away without the need to commit them, and you can later use stash pop to get those changes back. Now we will introduce another important concept, which is branches. Let's say we have our users working on the main branch, and at some point, user 2 decides to work on a new feature which they prefer to work on separately, but still in parallel. They can create a new branch, so first you will need to create a branch and choose a name for it, and then you check out to move from main branch to branch 1 in this example. Any other user can also join user 2 on the new branch, of course if the branch is not local and available remotely on the Git repository. Once the feature he is working on a different branch is ready, we want to merge it with the main branch, which means the changes made on branch 1 will be added to the main branch as well in this example. If you didn't edit the same files, the merge should be done automatically. Otherwise, you will need to merge manually if there is a conflict. We will show an example later of such a situation in the demo. Another concept that I think is important to mention is the pull request. It is simply a merge that just needs to be approved first. So a user can open a pull request, and usually there are other people responsible for approving the request. They need to review the changes, and they can also comment. So it's a way to open a discussion in the team before integrating the changes from one branch to another. So pull requests are used when review or feedback is needed. It's especially useful when working in a team, but you would merge directly if you are alone or on a small team working on the project. I also want to mention that pull requests could be used after you fork a repository. Now, what's a fork? Remember when we explained the clone in the beginning? Fork is different from clone because it creates a copy of a repository on your Git account. So all the commits and push will not be done on the main repo. They will only be applied to the forked repo, so you can do whatever you want on it, and you can still use pull requests to push those changes to the main repo you forked from if you want. So now that we know how it works, what are the tools we can use with Git? You can use command lines or a visual tool like Git Kraken, Source Tree, GitHub for Unity that you can find in the asset store. There is also a Visual Studio Git integration. You can easily use Git from your development environment and more tools. Today I will be using a visual tool because in game development, not only programmers work on a game, but also artists, sound designers, animators, level designers, etc. And we want them all to be able to contribute on the project and easily use version control tools without the need of any programming skills. But of course, if you also use command line and you're more comfortable with it, you can choose this option. Also, to use command line, the setup can be a little bit different depending on the operating system you are using. Another reason why today I will use a visual tool, as you only need to install it like any other software or app in your computer. Today I will use Git Kraken, which is available for Windows, Mac, and Linux, because I'm used to this tool, but feel free to use any other visual tools like Source Tree. They are more or less the same and provide the same possibilities. Today for this demo, I will be using the 3D game Kit Lite. Now first, we are going to use GitHub, which is a Git repository hosting service. You can also use other services like GitLab. So first you will need to create an account, or you can sign in from here. Now once signed in, you can click on the plus button here and choose new repository. This will allow us to create a new repo. So I'm going to call it version control demo. And for the description, I'm going to put a demo using Git. I'm going to keep it public, and you can choose to initialize the repository with a README file, and you can also choose a git ignore. I will skip these steps because I'm importing an existing repository. But just to show you, in the git ignore, you can here search for the Unity git ignore file. A git ignore file is a way to simply tell Git which files to ignore, which means that Git will not track those files. And I will show you later how the git ignore file looks like. But I'm not adding any of these two as I have an existing repository, and I'm going to show you in a moment the project that I will be using. So let's just click Create Repository. So now once we created our Git repository, let me show you the project that I will be using today. Today I'm using the 3D Game Kit Lite, and before adding this to my repository, I want to set up this project for Git. So first we are going to go to Edit, and then we go to Project Settings, and under Editor, you can find that we have this first option which is called Version Control, and in Mode, make sure that Visible Meta Files is selected. Meta files are important because if an asset loses its meta file, any reference to that asset will be broken. And then if you go to the asset serialization mode, make sure that we are using force text. This will help with the version control merges. It will allow Unity to store scene files in a text-based format. Let's just play the game quickly to see how it looks like. It's just a simple demo. I'm gonna go on and save project. And now let's add this to our Git repository. So first, I'm going to open Git Kraken. Here you can see that we have three options: open a repository, clone a repository, or start a local repository. Now before doing any of these, I'm going to go to Preferences. You can access it from here, or you can go to File, Preferences. And here you can find the different services that you can use with Git. So let's use GitHub. I'm going to click on Connect to GitHub. This will open this page to our default browser, so make sure to click Continue Authorization. Once it's done, you can see that we are connected here. Now, since I already have an existing project, I'm going to use this option, Start a Local Repository. And from here, I can choose the path. I can press here and Show in Explorer, and here I can find the path to my folder. So I'm going to use it here, and then I'm going to copy exactly the name to make sure that it's the same folder and put it here. And then make sure to add the Unity Git Ignore. I'm not adding any license, and I will go on and create the repository. So now once created, you can see that it detects that we have all those files. And these are unstaged files. You can see them this way by seeing the path, and you can also use the tree mode, which will allow you to see them like folders. And I'm going to stage all those files. And now we can add a commit message. So I'm going to call this adding 3D Game Kit Lite. And now I'm going to go on and commit those changes. Here we can see that we have two commits. This commit that we just made with all those files, and then we have the initial commit that you can see here. And here we have two files. We have the README file, you can actually click to visualize it, and you can also visualize the git ignore file I told you about earlier. So here you can find all the files that we are ignoring, like the cache directories, log files, etc. Usually you don't need to edit this template, but if for some reason you want to ignore specific files, then you can add them to the git ignore file manually. Now I'm going to click here to close this. And now it's time to push this local repository to the remote repository we created earlier. So I'm going to click push here, and this will ask me if I want to add a new remote. So I'm going to say yes. And this will allow me to actually add from a URL. So let's go back to the website, and we can copy this URL here. And here we can put it as pull and push the same. You can also keep the same name. So I'm going to copy and paste it here, and then you can do add remote. Now, once this is done, you can actually push those changes. It will ask you which branch we will push to the master by default. So I'm going to head on and click submit. And here we can see that it's pushed successfully. Now, if I go back to the website again and I refresh the page, you can see that it's added here, and we have the history of the commits, and you can find these two commits. So now our remote repository is linked to our local repository. Now I'm using another computer with another GitHub account. So first thing that we need to do here, I want to clone the repository that we just created with user1. So I need to go to this page and get this URL. I'm going to copy it and then go back to Git Kraken. And here, instead of starting in a repository like earlier, this time we are going to clone a repository. So I'm going to click here. I'm going to put the URL, and then you can choose the folder where you want to put it. I'm going to put it here in my projects. Now just click Clone the repo. Now once it's successfully cloned, we can open it now. And here we can see the history of the commits. And now I'm going to add the project. I'm going to put the path. And then I'm going to select the folder. And now once I have it, I can open the project. And now user 2 has also access to the project. Now I'm going to go back to Git Kraken. And let's say I want to create a new branch. So you can just click here on branch. And this will ask you to choose the name of the new branch. Here I will make changes by adding a restart method to the UI. So I'm going to call this branch UI restart. And just press enter. And now we can see that it's locally added. Let's go back to Unity. Here I can navigate to the scripts folder where I can find the game folder. And here I will open the UI one. Find the restart UI script and let me double click to open it. Now that my script is open, I'm going to add a restart method that I have already created. So I'm going to just paste it here, and then I do Ctrl S to save. Now when I go back to Git Kraken, I can find here the files I have edited and made changes on. So I can see the start UI script we just edited. I will click on stage file to add it. If I click on the file, I can see what I exactly changed. So I can see clearly that I have added the restart level method, and I have also removed this empty line. Now I'm going to just put the commit message, added restart method. And then I'm going to click this button to commit the change. Here I have another change in the project settings file. I don't want to commit this file, so I will click on this button to discard all changes. This will discard all the staged and unstaged files, which means all the uncommitted files. Now if we go back and look at the commit details, we can see that I have only this file changed and committed. Now I'm currently on the UI restart branch. I'm going to click push and send those changes remotely to the current branch UI restart, and then submit. Also make sure that you have the right to contribute to the Git repository. In case you get an error at this step, you can ask the first user who created the Git repository to invite you as collaborator to the project repo. Now we have both this UI restart and master branches. I would like to merge the changes I made on UI restart branch into the master branch. But I want these changes to be approved by the team first. So I'm going to use a pull request to let other users know that I want to merge my changes into the master branch. Before that, I just wanted to show you that you can merge by dragging and dropping the branch you want to merge into the branch you want to merge to. In this case, UI restart into master. This will open a menu to choose what you want to do exactly. So here you can merge directly if you want, but as I said, in my case, I want to make a pull request first. Let's go back to the website. As you can notice here, I can already see this message saying that UI restart had more recent pushes. And if I click here to switch to the new branch, I can see that there are 3 commits here, including the last one when we added the restart method. Now I'm going to go on and press compare and pull request. Here we can see that it says that we are able to merge automatically, so there are no conflicts on the files with the master branch. I will keep the added restart method for the message, and as you can see, we can also leave a comment if we would like to. And now let's just click on create pull request. Now that this step is done, let's go back to user 1. Now if we go back to the user 1 perspective, we can see that here we have those 2 remote branches, the master and the UI restart. Local, I only have the master because I didn't work on the UI restart. And here I can also see the same. So now you can see that the UI restart is 1 commit ahead of the master. And I can see that I have a pull request here. So let's go back to the website. And here, if I go to pull requests, I can see that there is this pull request. I can go on and open it. And here I can see merge pull request to approve it. So I'm going to do this. And I'm going to say merge, confirm. And now the pull request has successfully been merged and closed. So if we go back here to the code, you can see that we have this new commit over here. So now let's go back to our project. And let's say I want to make a few changes. So I'm going to select here, the player is Ellen. And then I'm going to go to the prefab mode because I want to edit a few things on that. Maybe let's first start by increasing the damage hit. So let's say I would put it to 6 instead of 5. Let's maybe change the color of this material here. So I will select HDR, we can make it green, purple, or maybe, yeah, a bit of orange, yellow. It looks like fire. That's cool. And now maybe we can go back here, and I will also make a few changes on that script that the other user also made changes on. So let's go to UI, and then I have this start UI script. And here I have an exit pose function that I have prepared. So I'm gonna go on and paste it here. And I also put the restart level to do. So I'm gonna do Control S. And then if we go back here, for some reason, we can also change the position to test new things. And then we can do Control S. We saved the scene now, but maybe we don't want to push it. So let's go back to Git Kraken. And now we can see that we have these few changes. So the first one here is the staff switch material. So I have changed the color, as you can see here on the material. So I'm going to stage that, change it, staff switch material to orange, I would say. I want to make another commit now with this start UI function. Again, I can select, so I can say add exit pose method. I'm going to also commit that. And I also made the change on the max hit point, as you can see here. So I'm going to stage this file and say change it max hit point on ln prefab. And I'm going to commit this as well. Now, I don't want to push the scene. And now, as you can see, we have those changes in master. But then you can see that there is another change that I didn't pull yet. So after committing, I need to pull it. And here it tells me that I have a merge conflict. Great. This is the conflicted file. When we click on it, we can see the different versions. So here we can see user A and user B, and we can decide which ones we want to keep. So here I added the exit pose function. You can add all of those changes by one. You can also remove one line, add one line. So you really can be super flexible with all of this. And now you can see that I also edited the restart level, but user B also added the restart level, and I want to use this one. So I'm gonna take this change from user B. So now I have both changes, the change from user A and the change from user B. For this line and for this function, I want to discard them, so I'm not gonna select them. And now after this, I have a preview of these, and I can see that these are the two conflicts are already checked. So now you can click on this save button here. And then let's say, save this output that I've prepared. And now it creates for you a commit message automatically to say that we are merging. So let's go and do commit and merge. And now, as you can see, we can easily pull successfully and push successfully. Now, if we go back to this page here and I'm going to refresh it, you can see that 18 seconds ago here, we have this new merge already applied. One thing that I also wanted to mention, when you have commits here and you want to stage them, you can either stage them, but if you don't want to stage them yet, you can press this stash button that I mentioned earlier on the slides. So you can stash few changes and then you can that way save them away. And then you can pop the stash when you press this button to get them back after you have pulled the changes on the repository. Now I want to show you another example. Now, if we type on Google, boot attack, Unity, you can find this project that we have. And I just wanted to show you this project so you can have an idea how a finished project looks like. So let's go on and do this to get the URL. One thing I wanted to mention also is you can fork the repository, as I told you earlier, so you can have your own copy. Then when you make commits or push, they're going to be pushed to that repository. So now if you go here and I do plus here, I'm going to do clone repository. And then I'm going to clone it here in the Unity projects. And I'm going to go on and press clone. And now we can open it already successfully. continue with LFS. No. Okay. So I just wanted to show you how it looks like. So here you can see that we have all those different branches, and they are somehow have different categories like bug fixes, demos, features, etc. And here we have those tags to stage the different versions. So you can here, for instance, click, see the files that have been changed, and see all the changes that have been made individually. And this is a very good example to see how it actually looks like when you have like a really full project within a team. And now it's time for the tips. Now, during the demo, we have shown an example of solving merge conflict, but usually we should avoid having them in the first place. You should always try to work on different scenes when possible. Each member of the team can work on a different scene and assign someone to be responsible for putting all the scenes together. Or you can use additive scenes to load scenes at the same time during the game. Use prefabs when it's possible. This will help you avoid pushing the whole scene if you only make the changes on a prefab. Use it also with the UI for the different parts of the UI, so you can edit them separately. Use scriptable objects to store your data. It's always a good idea to use them, but more specifically when you are using version control. If you have a cinematic or a cutscene on your project, you can nest timelines just like prefabs. So members of the team can work on different elements of the cutscene separately with no merge conflicts. You can use different branches per feature and per stage. Here I want to mention that there are patterns that you can follow, like Git flow, which relies on using multiple branches, so you can use different branches for the development, releases, features, hotfixes, and the master branch. There are other patterns like trunk-based development, which relies less on branches, so the whole team collaborates on a single branch called trunk. This avoids the merge conflicts that come from merging branches, but you will still need to merge if you edit the same files even on the same branch. Both patterns have their advantages and disadvantages, so if you're interested, feel free to dive deeper and experiment with them to see which one fits your project. And branches allow to work in parallel, and you can use branches and tags to manage milestones and releases. Now, a tag is like a branch, but once it's created, it doesn't change and can't have any more commits. Commit frequently. Enforce a policy of good commit messages within the team, which means that these commits should be clear, descriptive messages that will help you track down problems later during development. It also becomes easier to revert and undo, so you can revert back to a certain stage of the project easily. Use Git LFS if needed. So Git LFS is a Git extension that helps you to better manage large files. You would mainly use it if you have heavy assets like textures, models, audio, etc. Now today the main focus was on Git, but talking about large files, as you probably know, especially when working on games, file size can get really big. In this case, I highly recommend that you check plasticascm tool, as it's known for its efficient handling of large files. Also, let us know if you want us to do other talks about other version control tools like plasticascm. You can also use Smart Merge, which is a tool to merge scene and prefab files in a semantically correct way. And you can find more about Smart Merge by following this link. That's all for the tips today. Thank you so much for attending this introduction to version control. I hope you enjoyed it. Feel free to reach out to me if you have any question or if you would like to share your version control tips with me. Again, this is an introduction. More advanced content is coming, so stay tuned. You can also post questions on the forum in the Unite Now thread related to this talk. I will be there to answer along with the team. Thanks again, and see you soon for another talk.